In this in-depth conversation, Harvard physicist Avi Loeb explores a wide array of cosmic and scientific topics, centering on recent intriguing interstellar objects, especially 3I Atlas. The discussion delves into the mysteries surrounding these visitors from beyond our solar system, the potential for extraterrestrial technology, the challenges of space exploration, and the broader implications for humanity. Alongside these, Loeb touches on space science, academia's resistance to unconventional ideas, and the future of mankind's interstellar ambitions. Avi Loeb introduces 3I Atlas as the third recognized interstellar object, notable for its exceptional size, potentially comparable to a city such as Manhattan, and unusual trajectory within the plane of the solar system's planets. Unlike typical comets or asteroids, 3I Atlas exhibits a set of anomalies that challenge the prevailing assumption that it is a natural, icy object. Its path aligns closely with the ecliptic plane, an improbable coincidence if it were an unrelated interstellar rock. Additionally, images from the Mars Reconnaissance Orbiter showed an extension, or an anti-tail, pointing in the direction of its motion rather than away from the Sun, defying known comet physics. Loeb emphasizes the insufficiency of the standard comet explanation, highlighting the lack of water content typical for comets, and the anomalous non-gravitational accelerations that 3I Atlas experiences without evident gas or dust emissions. He critiques NASA's official statements declaring certainty about its natural origin without adequately addressing these irregularities. Instead, he proposes a framework ranging from wholly natural to fully technological, rating 3I Atlas around a 4 on this scale, while awaiting further observational data, especially about the speeds of its jets. The conversation traces the discovery of interstellar objects back to Oumuamua, 2017, Borisov, 2019, and subsequently 3I Atlas. These objects differ drastically in size and behavior, with Oumuamua displaying unexpected non-gravitational acceleration without a cometary tail. Loeb discusses the challenges in detecting and identifying such fast-moving objects, especially those smaller than a football field, given the limits of current telescopic surveys and the blurring effects caused by rapid motion. He also recounts his role in identifying an interstellar meteor striking Earth in 2014 through U.S. government satellite data, an event met with skepticism by some in academia, despite confirmation from Military Space Command. Loeb underscores the resistance to accepting data that challenge conventional wisdom, especially when coming from government sources or suggesting extraterrestrial origins. Loeb elaborates on the necessity of artificial intelligence, AI, for future deep space missions beyond Mars and the Moon. Due to light speed delays that prevent immediate human control, autonomous probes with onboard brains, capable of decision-making, will be vital. Human missions, while thrilling because of risk and direct engagement, are not always practical. Robots offer safer, cost-effective exploration options. He draws analogies to parenting autonomous children who venture out independently and emphasize how AI-enhanced missions represent the next frontier in human space exploration. Loeb also highlights the current absence of AI use in spacecraft, yet regards it as essential for interstellar endeavors. On the subject of returning to the Moon, Loeb expresses limited enthusiasm for considering it humanity's ultimate destination, describing Earth as the paradise requiring preservation. While the Moon offers valuable scientific opportunities, it is not the best long-term habitat for humans due to harsh conditions. Instead, he envisions constructing space habitats, self-sustained platforms with artificial gravity, nuclear energy, and protective environments that surpass mere planetary colonization. Loeb contrasts the enormous military spending worldwide with the investment needed to realize such ambitious space projects, advocating for a Manhattan Project-level commitment. Loeb discusses Mars's ancient history, noting that roughly half of its existence, for about 2 to 25 billion years, the planet had liquid water and a thicker atmosphere, conditions reminiscent of early Earth. He outlines the probable causes for Mars' atmospheric loss, such as a weak magnetic field exposing the atmosphere to solar wind stripping. He further explores the intriguing possibility that life, potentially even intelligent life, originated earlier or faster on Mars than Earth, and that microbes could have been transported between the planets via meteorite impacts, supported by rocks found on Earth of Martian origin, with preserved magnetic signatures suggesting a cool journey. The conversation touches on the presence of unusual isotopes like xenon 129 on Mars, an element otherwise associated with nuclear explosions on Earth, raising questions about its origin. Though some speculate it could be evidence of ancient nuclear activity, no definitive conclusions exist. Loeb stresses the importance of searching for technological signatures, not just biological ones, arguing that the scientific community should allocate equivalent effort and funding toward the search for extraterrestrial intelligence, including technological artifacts potentially scattered across planetary surfaces or traveling through the solar system. Loeb draws attention to the WOW signal detected in 1977, a mysterious radio burst from deep space, and its proximity to the arrival direction of 3I Atlas. He explains that the signal, although enigmatic, has been the subject of various natural explanations, but remains unexplained and invites further investigation. Regarding 3I Atlas, recent radio observations have set upper limits on any artificial radio emissions from the object, comparable to cell phone signals, but these observations are limited in frequency range and duration. Loeb advocates continued radio scrutiny to detect any possible technological transmissions linked to such objects. Throughout the interview, Loeb reflects on the resistance faced by those proposing unconventional hypotheses, noting the gatekeeping in scientific publishing and funding. He describes a conservative academic culture that discourages exploration outside established paradigms and rewards conformity. He contrasts this with other fields or sectors, such as AI research or finance, that embrace risk-taking and innovation. Loeb urges for humility in science, emphasizing the need to admit ignorance and welcome anomalies that challenge orthodoxy, rather than dismissing them to preserve status quo. Loeb addresses questions about government knowledge of extraterrestrial phenomena and the possibility of suppressed discoveries. While acknowledging that secrecy might exist for national security reasons, he argues that genuine scientific breakthroughs can rarely remain concealed indefinitely due to the collaborative and global nature of scientific inquiry. He recounts his engagements with governmental offices investigating unidentified aerial phenomena, UAP, noting the lack of compelling physical evidence publicly acknowledged, and stresses the importance of independent, evidence-based investigations through projects like the Galileo Project, which he leads. Loeb paints a vision for humanity's future that emphasizes building durable space habitats capable of supporting large populations, sustained by nuclear energy and artificial gravity. These would be more viable long-term homes than planetary surfaces like Mars or the Moon due to harsher environments and resource limitations. He also introduces the idea of crafting spacecraft as monuments meant to preserve human legacy beyond Earth, traveling to interstellar space to signal humanity's existence to possible cosmic neighbors long after Earth is uninhabitable due to the sun's evolution. Loeb emphasizes the vastness of cosmic timescales, noting humanity arrived late in the universe's history, and that many civilizations may have existed and perished before us. He cautions against anthropocentrism, proposing that other intelligences, if they exist, may be far more advanced, and that this could provide both a challenge and an inspiration to humanity. He discusses relativistic travel, where astronauts accelerating at Earth gravity could reach near-light speeds and cross the galaxy within their lifetimes, but with profound consequences for time experienced relative to Earth, leading to scenarios where explorers return to drastically changed worlds. Loeb shares his commitment to involving the public in scientific discourse, highlighting how curiosity about extraterrestrial life and cosmic phenomena resonates widely. He views this engagement as vital for supporting research efforts and inspiring future scientists. He actively communicates through platforms like Medium, producing accessible essays that invite readers to contemplate fundamental questions while lamenting the disconnect between elite scientific culture and public interest. The exploration of moons such as Europa and Enceladus is spotlighted as promising targets in the search for primitive life, featuring subsurface oceans beneath thick ice crusts warmed by tidal forces. While these environments might not foster complex life forms due to lack of sun-exposed land interfaces, they might harbor microbial ecosystems. Loeb regards the hunt for microbial biosignatures and technological artifacts as complementary endeavors. He critiques the heavy financial focus on microbial life while advocating for balanced investment in searches for advanced civilizations, including the possibility that probes or technological debris exist within the solar system or arriving as interstellar objects. Loeb explains current technological limitations in observing fast interstellar objects, particularly small or high-velocity ones that can evade detection due to brief visibility and the smearing of their reflected light across telescope exposures. He emphasizes the critical need for early identification and extensive multi-wavelength observation campaigns, including spectroscopy and radar imaging, to uncover the nature of these objects. The upcoming observational coordination around 3I Atlas's close approach to Earth represents a crucial opportunity in this regard. Imagining what extraterrestrial life might look like, Loeb rejects anthropomorphic templates influenced by human biology and culture. He envisions life forms with sensory organs positioned for 360-degree awareness, multiple limbs for versatile movement, and AI-assisted cognitive abilities. He touches briefly on historical and cultural perspectives, including religious views, noting that finding intelligent extraterrestrials could not only revolutionize science, but also humanity's spiritual understanding. He humorously references the idea that if such beings exist, humans might resemble small insects or animals to them, potentially even ending up as food. Loeb reflects on the Fermi paradox. Where is everybody? Highlighting the tension between the high likelihood of other civilizations given cosmic timescales and their apparent absence from our observations. He offers the possibility that extraterrestrials may be present but undetected, perhaps by choice or due to technological or observational limitations. The discovery of interstellar objects like 3I Atlas may hint at the presence of advanced civilizations, and increased scientific vigilance is needed to detect their signatures. Throughout the discussion, Loeb points out that funding challenges hinder ambitious space projects, proposing that a fraction of global military spending, which exceeds trillions of dollars annually, could transform space exploration and habitat construction. He underscores the contrast between the high costs of current planetary missions versus the potential benefits of long-term infrastructure investment, emphasizing the societal and scientific value of pursuing such goals as a shared human priority. Loeb allows for the possibility that advanced human or pre-human civilizations might have existed on Earth in deep prehistory without leaving clear technological artifacts due to geological changes and the passage of vast time spans. He evokes the importance of searching beyond Earth, in the solar system and beyond, for possible remnants or signals of intelligent life. Considering that the archaeological record on Earth alone may be insufficient to fully answer such questions. The physical realities of special and general relativity are explored, including time dilation effects for spacecraft approaching light speed through continuous acceleration. Loeb discusses how relativistic travel could allow humans to cross the galaxy within subjective lifetimes, yet lead to profound temporal disconnects with Earth's timeline. He discusses how these effects challenge ideas about interstellar colonization, communication, and the social impact of such journeys. The possibility that unidentified anomalous phenomena might exist in Earth's oceans as well as in the sky is raised, noting that much of the ocean remains unexplored and that pressure and temperature conditions underwater could offer refuge or operational advantages for unknown technologies or life forms. Loeb acknowledges that scientific exploration of oceanic anomalies should be part of a comprehensive search for unknown phenomena. Loeb discusses cooperation among NASA, ESA, and other international agencies, noting both joint projects and areas of national competitiveness, such as China's active lunar and Martian missions. He points to how space science spans borders and is shaped by political and economic factors, while advocating for open collaboration in searching for interstellar life and studying strange visitors like 3I Atlas. Looking ahead, Loeb highlights the December 19th close approach of 3I Atlas to Earth as a pivotal moment for data collection. Coordinated observations from many observatories worldwide and space telescopes may soon clarify the object's nature. He stresses the importance of measuring velocity and composition of jets emitted by 3I Atlas, with data potentially confirming or ruling out artificial propulsion. The upcoming opportunity to leverage the Juno spacecraft near Jupiter to detect potential probes or activity is also underscored. Throughout, Loeb intertwines scientific discussions with philosophical reflections, emphasizing humility in science and cautioning against arrogance. He highlights the importance of embracing anomalies and unknowns as avenues to discovery. He envisions discoveries of extraterrestrial technology or life as potentially transformative for human self-understanding, culture, and even religion. Such revelations could unify humanity in shared curiosity and purpose, moving beyond terrestrial conflicts toward cooperative exploration.